Hi, good afternoon to you, my dear students. This is Geeta Miss. Hope you and your parents are in good health. You are in 10th standard, which is a very important year in your life. Already you must have got advices and instructions from your parents and dear ones about the importance of this academic year. By hard work and dedication, you can achieve your goal. Concentrate on whatever is told to you. Work hard that day itself only. This is the key for success. Today, whole world is suffering from COVID-19, but we all shall overcome this condition and will start leading a usual life. May God give you strength to overcome these difficulties. Due to lockdown, we were unable to start tuition classes, but from today onwards, we are going to start video classes. We will start with physics. There are 2 books in science and totally there are 5 chapters in physics.
In science part 1 and 2, the chapters in physics are electricity in part 1, balancing effect of electric current in part 1, light, reflection and refraction in part 2, the human eye and the colorful world in part 2, sustainable management of natural resources in part 2. Today we are going to study regarding electricity. It is the chapter 12 in part 1. Today I am going to teach the topic electricity. In ancient times, people had no knowledge about electricity. They were living in darkness by burning the oil lamp. But as science and technology developed, electricity was discovered and today the modern society depends upon the electricity. The industries, the factories, the home appliances, even the video what I am presenting you before works with electricity. Electricity is nothing but it is study of charges. In electricity topic, we are going to study these subunits. They are electric charges, potential difference, Ohm's law, resistance and its dependence, heating effect of electric current and electric power. To understand about electric charges, we should know about friction. In 5th, 6th, 7th standard, you have studied about friction. What is meant by friction? When 2 bodies are rubbed against each other, there is an opposing force called friction. One example I can give. When a man is walking on a road, his feet touches the road. He is applying force on the road. At the same time, the road is applying an opposing force on the feet, due to which the man is able to walk, and that opposing force is called friction. Similarly, second example let us take. Let us take a glass rod and a silk cloth. Glass rod and silk cloth are matters, and we know that matters are made up of molecules and atoms. In an atom, the fundamental particles are electrons, protons and neutrons. In any matter, the number of electrons is always equal to number of protons. Let us rub silk cloth against the glass rod. When we start rubbing the silk cloth on the glass rod, the glass rod loses the electron and the number of electrons becomes less and the number of protons becomes more. So now the glass rod is positively charged. At the same time, the silk cloth gains the electrons, due to which the number of electrons becomes more than the number of protons. So the silk cloth becomes negatively charged. This we call it as charges. Now let us try to understand what is meant by electric charge. To understand regarding electric charge, the concept of friction charges gave a scientist called Coulomb to make him explain regarding the electric charges. Let us try to understand now what is meant by electric charge. It is an internal property of any particle which exerts electric force on another particle. This is called as electric charge. There are 2 types of charges. positive charge and negative charge. What is meant by positive charge? The charge carried by protons of an atom is called positive charge. We know that protons have positive charge, so the charges carried by these protons is called as positive charge. Negative charge means the charge carried by electrons of an atom is called negative charge. Electrons are negatively charged, so when electrons carry this negative charge, we call it as negative charges. There are properties of electric charges. Before we try to understand the properties of electric charges, you all know about the magnets. Let us take two different magnets. Each magnet is having two poles, north pole and south pole. Let us try to bring the north poles of the two magnets nearer to each other. We will find that the poles are moving away from each other, which is called as force of repulsion. At the same time, when we bring the north pole of one magnet to the south pole of the another magnet, the poles attract each other, which is called force of attraction. So, similarly, we can also give the properties of electric charge. We can say that the like charges repel each other. Here you can see that two positive charges are brought nearer to each other. They move away from each other. This shows that a repulsion force is acting. When two negative charges are brought nearer to each other, we can find that they are also moving apart. This shows there is a repulsion force between the two negative charges. Now I explained you the first property of electric charge, that is like charges repel each other. There are second and third property also. Let us see what the second property says. Unlike charges attract each other. You can see here a positive charge and a negative charge is there. When these charges come near to each other, they are attracted by the force, that is force of attraction. Third property is called electric charges are conserved. What is meant by conserved? We know that before the transformation, whatever the total number of charges are there should be equal to total number of charges after transformation. I can take an example of glass rod and silk cloth. In glass rod and silk cloth, before we rubbed, the total number of charges present in both will be equal to the total number of charges after rubbing the silk cloth on the glass rod. The number of charges remains the same. Thus we can say that electric charges are conserved. Symbol of electric charge is capital Q or small q. The SI unit is coulomb. The smallest value on any charge, that is on electron or proton, is 1.6 into 10 to the power of minus 19 coulomb. We can find out the total number of charges by using this equation. Q is equal to N into E, where N is called number of electrons and E is the value of charge on electron. 1 coulomb has 6.25 into 10 to the power of minus electrons. We can derive this by using the equation Q is equal to N into E, where Q is 1 coulomb, E is 1.6 into 10 to the power of minus 19 coulomb. Substitute the value of Q as 1, N into value of E 1.6 into 10 to the power of minus 19. N is equal to 1 by 1.6 into 10 to the power of minus 19. Removing the decimal from the denominator, adding 1 0 in the numerator, then 1 0 becomes less over here, so it becomes minus 18. 10 by 16, if you divide it, you will get 6.25. Thus, we can say that 1 coulomb has 6.25 into 10 to the power of minus 18 electrons. Next, we will see regarding electricity. The flow of charges through cross-section of a conductor is called electricity. There are two types of electricity: static electricity and current electricity. Static electricity means where the charges are at rest is called static electricity. For that we can take an example. You have played this in your younger ages. Take paper, Tear it into small pieces, take a scale and rub the scale on your head and try to bring the small papers nearer to it. You will see that the papers will stick to the scale. This shows that already scale had charges which are in rest position. When you rubbed it, it became active and it attracted the small pieces of papers. Thus, this we call it as static electricity. Current electricity means where the charges flow freely through a conductor. We call it as current electricity. The charges should be in motion. Then only we can call it as electricity. To make the charges to flow, it requires a material medium. What is meant by the material medium? What conditions should be there in a material medium? Any material medium should has two conditions. First condition, it says that it should have free electrons or protons or ions. That is, it should have charge carriers. Second, the atomic size should be more. What is meant by atomic size? It is said as the distance between the nucleus and the outermost shell of an atom is called atomic size. All the electrons are binded in their orbit and they are attracted by the nucleus. As the orbit increases, the attraction power decreases. So the electrons are left free in the outer shell, which can move very easily. Those electrons are called delocalized electrons, and that plays very important part in current electricity, and flow of those electrons makes the electricity. Electric current means rate of flow of charges through cross-section of conductor. The symbol used for electric current is I. The SI unit is ampere. It can also be defined as the ratio between the total charges or net charges passed through cross-section of conductor in unit time. So we can derive a formula I is equal to Q by T, where the unit ampere came because the SI unit of charge is coulomb and the SI unit of time is second. Coulomb per second is called as ampere. This was given by a scientist, Henri Marie Ampere. So it is named after that person as ampere. Even the current can be measured in smaller units. The smaller units of current are milliampere and microampere, where 1 milliampere is equal to 10 to the power of minus 3 ampere and 1 microampere is equal to 10 to the power of minus 6 ampere. So, cross section of conductor. What is meant by the conductor? Last I told you regarding the material medium. So, material medium are those medium which allows the charges to pass, and the medium which allows the charges to pass is called as a conductor. For example, copper, silver and aluminium. Because in copper, silver and aluminium, more number of free electrons are there and its atomic size is more. Last time I told you that if atomic size is more and more number of free electrons are there, it becomes a good conductor. So these are the best conductor. But some materials are there which do not allow the current to pass through it or not allow the charges to pass through it. Such material are called as insulators. For example, plastic, rubber, wood, they are called as insulators because they don't have free electrons or their atomic size is not more. So they are called as insulators. Electric field. What is meant by electric field? Let us take two charges, a positive charge and a negative charge. The space around the positive charge, where any negative charge comes, it attracts it. So an electric force is there surrounding this area. In this area, the electric force is there. That is called as electric field. Even if you take a negative charge, the space surrounding the negative charge, where any positive charge will come, it will attract it. That space or the region is called as electric field. how in a magnet we have the magnetic field where we keep a bar magnet, and the area surrounding that bar magnet where the iron filings get attracted, that area is called as magnetic field. In the same way, this is called as electric field. We have to know about the electric field to get the knowledge about electric potential. What is potential means the strength. Electric means the charged particles. What is the strength of a charged particles? Let us try to understand the electric potential. Let us take that this is a negative charged particle. This is the electric field. A positive charge is present at A and it has to be moved to a point at B inside the electric field. Now, at A, the positive charge is at rest. So, an energy should be applied to the positive charge. So, it starts moving and it reaches point B. Then, we can say that it has an electric potential. What does it mean? The work done by a unit positive charge. A positive charge is away from the electric field of a negative charge. This positive charge is to be moved from point A to point B. It is in rest position. Energy should be applied to the positive charge such that it starts moving and reaches point B in the electric field. We can say that the work is done. Already 9 standard you studied about the work done. A is the initial position, B is the final position. So displacement is there. Whenever displacement takes place, work is done. So we can define electric potential as work done by a unit positive charge to move from outside the electric field to a point or a specific point inside the electric field is called as electric potential. Now we'll go to the next topic, which is called as potential difference. What is meant by potential difference? We know that there are two terminals in any electrical appliances or in a battery. The difference between the charges between the two terminals is called as potential difference. It is also the work done to move the positive charge toward, that is from positive terminal to the negative terminal and from the negative terminal to the positive terminal. It is called as potential difference. I can explain you by taking one more example. Let us take two conductors. I guess by taking this diagram, let us take two wires, a wire which is rich in electron and a wire which is deficient in electron, means protons are more. Let us connect these two wires. What we will see that the electrons from the rich region starts moving to the deficient region till in both the wires the number of electrons becomes equal. That means the potential difference can be explained as the movement of unit charge from one point to the another point. We say the work is done. So the work done by a charge to move between 2 points is called as potential difference. It is denoted by letter V. V, a capital V, which means it is a potential difference. It can be measured by a unit called as volt. The measuring apparatus used for potential difference is voltmeter. Formula for potential difference is V is equal to W by Q, where W means the work done and Q means the charges. Let us see here some examples based on the potential difference. If how much work is done in moving a charge of 2 coulombs across 2 points between cell whose potential difference is 12 volts. Let us try to understand this example. Here, the total charge is given as 2 coulombs and the potential difference is given as 12 volts. So we can write down given as Q is equal to 2 coulombs, V is equal to 12 volts. We have to find out what is the work done. Let us write down the equation. V is equal to W by Q. Let us substitute the values. 12 is equal to W by 2. Nothing is there, it's 1. So let us cross multiply. 1 into W is equal to 2 into 12. Therefore, W is equal to 24 joules. Thus we got that the work done by this particular charge is 24 joules. Similarly, we can see the second example. How much potential difference is there between 2 points if total charge is 3 coulombs and work done is 27 joules. Let us try to understand this example. In this example, the total charge is given as 3 coulombs and the work done is given as 27 joules. Let us write down the given. In given we can show that W is equal to 27 joules, Q is equal to 3 coulombs. So, by writing its formula, we get V is equal to W by Q. That is equal to 27 by 3. 3 ones are 3 nines are. That means 9 volts difference is there in that particular circuit. Let us see the sums based on electric current. We already saw that I is equal to Q by T. Here in this sum, let us see. A current of 0.5 ampere is drawn by filament of an electric bulb for 10 minutes. Find amount of electric charge flowing through circuit. Here, the current I is given and the time T is given. So let us write down what is given. I is equal to 0.5 ampere. T is equal to 10 minutes. Now we know that the SI unit of time is seconds. This is given in 10 minutes, so we should convert it into seconds. We know that 1 minute is equal to 60 seconds, so 10 into 60, we will get 600 seconds. Now we'll see, take the formula. I is equal to Q by T. Let us substitute the values. The value of I is 0.5 is equal to Q we have to find out. Let us keep it as it is and write down the value of T, which is 600. Now, we know nothing is there, means 1 is there. Let us cross multiply. Q is equal to 0.5 into 600. 6 5s are 30. These 2 zeros you carry down as it is. 1 place of decimal means point. So, total charges flowing in that particular filament of an electric bulb is 300 coulombs. Let us see now the second example. In second example, it is given in an electric circuit, total number of charges flowing is 240 coulombs and time taken is 2 seconds. How much current is flowing? Here we know that already the charges is in coulomb and the time is also in second. Let us write down what is given. Q is equal to 240 coulomb T is equal to 2 seconds. Let us take the formula. I is equal to Q by T is equal to 240 by 2. If we cancel, we get it as 120. So, it is 120 ampere current is flowing in that electric circuit. What is meant by electric circuit? Let us now see. A closed continuous path of current flowing through conducting wire is called electric circuit. Let us see the simple electric circuit. Here we can see that the conducting wire is given by a straight line. This is a symbol represented for bulb. This is a symbol for an ammeter. What is an ammeter? It is a device which measures the flow of current. This is the switch and this is the cell. Now we can see that the positive and negative terminals of the cell, the ammeter and the bulb are always connected in series in a simple electric circuit. What is meant by series? Means the bulb and the ammeter are side by side. They are not connected one below the other, that we call it a series. This is a simple electric circuit diagram. In a simple electric circuit diagram, the flow of the current should be denoted by arrow mark. This is very important to denote the arrow mark. It shows where the current is flowing from which end to the which end. So this is simple electric circuit. Let's understand what is meant by 1 coulomb. Already I explained you, coulomb is a unit for measuring charges. The net charges is measured by unit called as coulomb. 1 coulomb means it is a charge present in a body when it contains 6.25 into 10 to the power minus 18 electrons. Means if a body is having 6.25 into 10 to the power minus 18 electrons, it means the body is possessing 1 coulomb of charges. Similarly, what is meant by 1 volt? Volt is the unit used for measuring potential difference. We can say that 1 volt means when 1 joule of work is done to move a charge of 1 coulomb from one point to another point is called as 1 volt. We know that volt is given by formula V is equal to W by Q, where W is the work done. The SI unit of work is joule and the SI unit of charge is coulomb. So we can say that joule per coulomb is called as volt. 1 volt. 1 volt means 1 joule per 1 second. That means 1 joule of work should be done to move 1 positive charge or negative charge from one point to another point, but that is the charge has 1 coulomb in it. So moving 1 coulomb of charge from one point to another point is called as 1 volt. Regarding the electric circuit, we can also say that we have a circuit diagram. What is meant by a circuit diagram? It is a schematic representation of closed path of flow of current through different electric components by using their symbols is called as electric circuit diagram. Symbols of commonly used components in circuit diagram is given in your textbook on page number 97, where a cell is used by drawing a long line and a short line. Long line represents positive and a short line represents negative. A battery is combination of 2 cells is called as battery. The key or the switch is represented by two half circles, which we call, one is called as the closed, when we say that when plug is open, there will be the symbol is used in this way. When plug is closed, it is used in this way. A wire crossing with joining, electric bulb, resistor, variable resistance, ammeter and voltmeter as shown in the symbols. This we use for representing a circuit diagram. We can't show ammeter, voltmeter, bulb or batteries as it is. So, for convenient method, these symbols are used for showing a circuit diagram.